So today we'll be solving a slightly harder problem. We'll just only do one problem and we'll go through this one step by step. So in this example right here, we have a 30 volt power source connected to a few resistors, R1, R2, R3, and R4 of various different resistances. We also have a dependent voltage source of 2 times current IX. And looks like IX is specifically going to be this current right there. Looks like IX is going to be the current that goes through the series combination of R2 and R3. Our main question that we need to solve, A, is determine what IX actually is, the value of that, and that's going to be something in amps. And then B, calculate the voltage across each of these 4 resistances. So let's get started. This should be a pretty straightforward type of question. So let's start it right here. So step 1, find the equivalent resistances. This is going to involve R2, R3, and R4, since those are the parallel combinations of resistances. So in this case, R23 is going to be equal to R2 plus R3, which is 35 ohms. And then R parallel is equal to 1 over R4 inverse plus 1 over R23 inverse, which is equal to 1 over 5 plus 1 over 35. Make sure that both of these are inverted, meaning that that answer is going to be 4.375 ohms is going to be R parallel. This is going to be the value that we're going to plug into our next step, step number 2. Let me scroll up a little bit. Step 2, establish Kirchhoff's voltage rule. So in this case, since we already have the parallel combination of this entire part of the circuit, we can boil that entire thing down to this one resistor of 4.375 ohms, meaning that we can tackle this remaining part of the circuit now. So in this case, we always know, since we're following Kirchhoff's voltage rule, that the sum of all voltages over that one loop must be equal to 0. So in this case, the equation of Kirchhoff's voltage rule is going to look something like this. 30, our independent voltage source, is equal to I total, the total current, multiplied by R1 plus 2 IX plus I total times R parallel. So the I total times R1 comes from this value right here. The I2 times IX is going to be our voltage source that we have right here. And the I total times the R parallel is going to be exactly what we solved for the previous question. So this is the equation that we're going to end up solving. However, the issue is that we don't know the value of I total or IX, meaning that we have to solve for that at some point. Fortunately, we can use the current splitting formula. In this case, the current splitting is going to be the IX and the I total, and we can write that as step number 3. So step 3, current splitting or current dividing. That formula is going to look a little bit something like this. IX is equal to I total times R4 over R4 plus R23. We can solve this, meaning I total multiplied by 5 over 5 plus 35, the values that we got from our previous step. And this can be equal to 0.125 I total. Another important value that we're going to plug into our previous equation. So once we substitute this value into there, after substitution, our equation is going to become something like this. 30 is equal to I total R1 plus 2 times 0.125 I total times or plus I total times R parallel, which is going to be equal to 4.375. Now we can simplify this, meaning 30 is equal to 10 I total plus 0.25 times I total plus 4.375 times I total, meaning we get a value of 30 is equal to 14.625 I total. And that means after calculating all of this, I total is going to be equal to 2.051 amps. Now we still haven't solved the problem yet because since we have I total in this case, but do we actually have IX? That is the main question, and we do not have that yet. However, we can simply use this formula that we had up here and multiply the 1.25 by the 2.051. It's going to be a pretty simple formula in this case. So I sub X is equal to 0.125 multiplied by 2.051 is going to give us roughly 0.2564 amps, which is our final answer for step number 8. Now, our part number 2, question B, is going to be calculate the voltage across each of the 4 resistors. This shouldn't be that hard. We have the values of the resistors and we have the values of all the currents that go through those resistors. Therefore, a simple Ohm's law calculation shouldn't be that bad. So, part B, let's go. Voltage R1 is going to be equal to I total multiplied by R1 equals 2.051 times 10 is going to be 20.513 volts. VR2 is going to be something very similar. So VR2 is going to be this 15 ohm resistor right here. That 15 ohms multiplied by IX is what we're calculating. So IX times R2, that is going to be 0.2564 times 15 is 3.846 volts. That is VR2. Now VR3 is going to be exactly the same. I sub X times R3 is going to be 0.2564 times 20 ohms will get you an answer of 5.128 volts. And then finally, VR4 is going to be the summation of the voltage across R2 and R3. So therefore, all we need to do is VR2 plus VR3 is going to be 3.846 volts plus 5.128 volts, the summation of this value and this value. And that'll get us an answer of 8.974 volts. So this right here is our final answer for part B. So a pretty straightforward problem. In the beginning, it looks very difficult, but we can solve this problem in a couple of few easy steps. So if you want more videos and tutorials on different circuits concepts, please visit us at voltagelearning.com. And until then, please be sure to like, comment, and subscribe. Until next time, we'll see you guys later.